it requires three components. The first one is content, the second one is interface, and the last one is the engine. So we have many applications over these 2 decades. So for example, we have the computer latency and literacy, and also conceptual physics, biology, critical thinking, mathematics, electronics, and IDOT literacy. So you will see the user interface will vary with the years passing, so it looks better and better. It's not only work on the Windows application, but also on the web-based services, and also the 3D demonstrations. So after talking about application, we will start worrying about the content. So in this slide, I'm showing a classical script for the auto tutors. So you will notice there's multiple elements. Let me put the pointer here. So there are a lot of information here. So for example, it have the learning record store information. It have a module called learning characteristic curves, and also the major conversation part for auto tutor scripts, and also the multimedia information here, and also something like learning object metadata, and some configuration for shareable knowledge objects. So there are so many sections here. So you may think about it may be too long for scripts. But for the current phase, we only focus on the basic function, which is just the conversation part. So the component or the section we care about is only the 5, which is highlighted here. So the first section called agents, which define the personality of the avatars by stylistic language used for feedbacks, like positive, neutral, and negative. We once got a feedback from one of patient is about they don't like the feedback from our tutor because it treats them like a school kid, but not an idol. So we really realized how this stylistic language will affect learnings. And the second one is called speech acts. So this section usually defines the regular expression used to capture the certain user feedback types with strong keywords. Like yes, no, and for another example, you can say confused. It can also capture the feedback type like nation if you can capture the keywords. The third one is called rigid text. It's used to as a predetermined interactions conversation among the computer agent. Usually, is used to handle the opening and closing, as well as the transaction during the questions. And the fourth part section is a tutoring package, which implement the expectations, misconception, dialogue of our tutor. And the last one is rules, which is a lot of bunch of if-then using the parameters to guide the conversation to a certain directions based on the user's input. So to develop a qualified auto scripts usually require a lot of understanding of the system, especially the basic 5 components I just talked about it. So here I give a pipeline how system loads the scripts. So first, the UI will load scripts using the GUIDs, and it will load information from script like the agents, roles, the register packs, and the questions. Then after first input from the users, a bunch of semantic analysis will be run and give a lot of matching. And based on these results, it will trigger different rules and direct the conversation to a different direction based on performance of the users. And then these kind of import and matching will repeat for several turns until the EMT structure was finished. Then the conversation will be end. So insight actually is implied besides the pipelines of the conversation, we also need to consider about how to write the correct questions and the components under the construction of the EMTs. Furthermore, you can see our tutor is a system didn't limit it in the certain domains. So to develop the content, usually you will require multiple domain experts and the linguistics and also the instruction designer, so that to do a teamwork to authoring content. The domain expert usually will create the knowledge structures and the learning content, and the linguistic will make sure the language is properly stated, and the instruction designers will organize and manage these learning objects and make courses. So usually, because our tutor is more like a natural language system, so usually we require a natural language expert to handle the natural language issues happens in the authoring course. So overall, the authoring, our tutors have several problems. The first is extremely time-consuming and high cost. So we want to lower the cost, and we also want to reuse some of old content to reduce the repeat authoring content. And the second is trying to lower the barrier to do the authoring, because usually it takes several weeks to train some new grad student to do the authoring. So the next part I will talk about what the current tutor script authoring situation in the GIFT. So we have multiple methods to assess the tutors. The first one is the offline one, which you can find in the desktop control panels. So after you open the control panel, go to the web browser tab, and you will find this tutor script authoring tools here. After clicked it, it will direct you to a new tab, and you will select this create tutor scripts. It will direct you another tabs, asks you to give the permit to GIFT to have access to this tutors. And for the online version, which you can access it via the GIFT authoring tools. So once you drag the authoring course object, you will find a section called tutor conversations. You just need to drag it to the next box of the tree and click the little green plus button here. You will see the same tabs and the navigations. Then you will go into the web server-based tutor tools, authoring tools here. So if I magnify a little bit, you will find the tutor authoring tools have a lot of tabs and modules. But most basic one is the file component I just mentioned above, to have the conversation without any multimedias and other functions. So the problem for the current process is the first is the Flash is not supported by any browser at the end of this year, which the Lite is a Flash. So we will definitely want to improve this to fix these issues. And the second is it's not supported teamwork simultaneously. So as I mentioned previously, tutor script actually involve a teamwork not only from multiple domain experts, but also from linguistic and also from the instruction designers. So we want each people can contribute their own parts simultaneously on a script. So we would prefer the authoring tools to handle these complicated situations. The last minor issues for current authoring tools is we don't have a stable service usually due to the latency, so we will have several different issues during the authoring tours. So what we have done is as we mentioned at the first page, I implement the local Tutor script editor here. So take advantage of the existing XML editor in the Gift. So first, I replaced the XSD files behind the authoring tours. So once you click it, it will not really bring you the original CAT script, but the Tutor scripts in this case. So once you click it, you will see the script actually components of 5 major sections I mentioned about previously. So you are trying to fill each sections by each entities. Any valid entity will be in blue, and so that you will fill everything which marked in red until everything is in blue. Then you can save it. So here I'm showing if you're trying to load altitude square with a different schemas. I mean, a little bit different in the structure. For example, they have more function modules like LCC, or it have the module of learning object metadata, then you will not be able to open the authoring tours. So this validation actually is quite good. So we are thinking about once we fix the schemas, then we can probably, by using this validations function to check whether a script is probably be authorized and have any potential issues directly. So this is the current work we have done. So talk about the future works we want to get further on this project. The first one is to improve the schemas so that we can adopt more modules and functions from our tutors. At least we want to support the functions such as the learner characteristic curves and the multimedia interactions, because the many research have shown these two, especially the multimedia interaction, have a great effect on users' learnings. And also, we want to adopt the learning object metadata, which will stand for IEEE. This would be good when we trying to organize these learning objects and help the instruction designer to figure out how to construct a good knowledge space. Part work we're trying to do is trying to redesign and make content authoring process to support the collaborations. So this is issue we're trying to fix for a long time. So we're trying to allow multiple people to contribute their own parts to the same script at the same time. So to achieve this, we can divide the authoring into several parts. So for example, like the unit of question or unit of answer, so that there will not be any conflict when multiple people working on the same, I would say, learning objects. So we have already developed a similar concept authoring tool based on the Google applications or services. We're trying to move the same concept and mechanism from that one into the Gift to see how well it goes. And also, we want to implement XAPI into the authoring tools because we're trying to using XAPI to check how well does this content author can create the content, how these steps and decisions will affect the quality of the scripts. That we were using this data to run the usability studies, and also, like I say, to check the content qualities. The XAPI data at this moment will be very useful. And also we can run several surveys to collect the data from these authors, and as well as the participation which we're using the auto tutors. So that's much for the presentation today. Thank you for your attention. Do you have any questions?
Yes, thank you for your nice talk. Yeah, I have a quick question. Your script looks like a XML form, or what kind of form? Can you make some template to make this as easy as you fill the form, like a Microsoft Excel, like this?
Yes, that's a good question. It's an XML script, and we have already tried with the form-like authoring tools, so that they can just fill the forms and fill everything. The problem I would like to point out for the form-like is, as I showed you in earlier, let me see. So the content part actually is very huge. So even you fill with a form is too much and overwhelming for a single content author. That's why I want to point out how important the collaboration is. So we want to divide these content author into several works involving multiple content experts. So it will be easier for them, to put everything together.
Sure. If I can ask another question, if I'm interested to extend your work, for example, you mentioned about the teamwork frame, and if we want this tool, not only conversation with the individual, but with the team of students, can we get your app or say plug in to install in our own gift system? You said you changed the first XML, then you connected your tool to the gift. Do you have this to help us if we are interested to further to develop some other features?
So currently, you can using the AutoTutor modules in the gift. But AutoTutor right now is a third-party web server-based components in the gift. So we're trying to move the third-party web server-based into integrate into the gift, so that you don't really need to be bothered by the problem of the server of the authoring tools, what we actually suffer right now. So that's the purpose. But if you want to have the ability to use the AutoTutor for right now, yeah, you can do that in the gift.
Let me add a little bit, because right now that we actually have the called ACE engine that is installed in gifttutoring.org. I think also is packaged if you just download, and then you can install the server on your own, but it's not as user friendly. Right now, if you want to work with this and do the team, we have not really implemented the team, like a true team yet, but we can have mimic multiple avatars to interact. But in this case, user only one. We do not have a multi-user interacting with the same auto-tutor. We can mimic multiple auto-tutor interact with single user.
Okay, I see. Oh, thank you.
Thank you so much. Thank you, Dr. Hu. Yeah.
So this is Ben Goldberg. It's worth noting that currently our Gift Cloud instance supports collaborative authoring. So if you're going to host your own kind of server instance of Gift, I would recommend kind of cloning off of the most recent version. Mike Hoffman, do you have anything else to add to that? I know that we're also looking at implementing concurrent authoring. so that multiple individuals can be in the same authoring tool and manipulating areas all at the same time. That is not supported at the moment. But how to kind of incorporate new authoring approaches, Mike, what are your thoughts?
Okay,
Yeah, I mean,
that's great.
currently the granularity of concurrent authoring is at the course level. So while you can share courses with lots of other users, you can only have one single editor at a time.
Mhm.
And so what Ben is alluding to is to kind of lower that granularity level to maybe even a course object or subcomponent. So then you can have multiple people in the course creator, the GIFT course creator at the same time.
Okay.
But that is actually the reason that we want to just use native GIFT. So as soon as you have that available, then we can directly use. Instead, we develop our own collaboration kind of things. I want to use, we want to use native GIFT authoring as much as possible. So directly take advantage of what you have produced for the next version.
So Mike, how do we get them their own VM with the latest build?
So you want this hosted in AWS, or is this just a locally running GIFT instances? What do you?
I mean, we should be able to do an AMI, right?
Yeah. Yeah, so the AMI comes with no GIFT instance, and then you can put whatever, GIFT instance you want, whether it's a public release or a internal release.
Okay.
So Shangan, offline, we can coordinate that to make sure that you're working with the latest, so that you can at least support the course sharing for authoring in the near term.
Thank you for the suggestion and advice. Is any other questions?
Well, talk about the collaborative developing.
Mm-hmm.
Practically, I like to have both cloud version and my own native version in my own computer. I can use this developing collaborative in the cloud version and then zip it, export, and then import it to my own native version. Then I have more control to the external systems or experiments.
Yeah, see right now, even the current version, when Lija was showing that you add it, and that is located in GIFT server, but that specific link, it's just a web service, RESTful service pointing to an XML file kind of generator. So if you actually do that, you can have your other server. The only thing that you need to do when you compile, because GIFT does not want to, or does not want you to link to other links. So if you have a local version, you can make that happen, but not the cloud version, not the GIFT cloud, but maybe your own cloud, you can make it happen because there are some policies in GIFT cloud.
Yeah, we have our own cloud, our own server. That will be more flexible.
Yeah, we've done a lot of work to make sure that not only courses are backwards compatible, but that they can be transported between the server instance of GIFT and local instances of GIFT.
That's critical.
And then the same architecture is used in both server and local. It's just flipping a couple flags, changing a couple settings, and now you're in server mode versus desktop mode.
Yeah.
Okay. Any more questions? We still have a couple minutes. Or any other points that someone would like to raise? All right. Well, thank you.
Thank you.
We're going to go ahead and move on to the next talk. We have Stacy Sokoloff and John Merrihew up next. They're going to be talking about trainers and fighter pilots and using GIFT. Stacy, are you out there?
Yes, I am.
Okay.
Let me.
And John Merrihew.
Hey, John. So don't feel rushed. We're a couple minutes ahead. And if you hear a bell, that's just your 5-minute warning.
Sure. All right. Can you see my screen?
Yep, you're good to go. Thanks.
So trainers and fighter pilots, they seem like very different people, and in many ways they are, but they do have some things in common. First of all, they both have to make complex, time-sensitive decisions in a rapidly changing battle space. They're focused on different things. Fighter pilots, of course, on enemy actions, aircraft state, weather, things along those lines, while trainers are focused on trying to make sure that the learner progresses through the training exercise and stays appropriately challenged and engaged. But despite their differences, they can both benefit from a decision-making framework. And one such framework is the OODA loop, or the Observe, Orient, Decide, Act loop, that was created by Air Force Colonel John Boyd. And even though it was created for fighter pilots, it's been used in many domains. So one example, the Observe, Orient, Decide, Act loop is actually pretty simple, easy to understand. So an example is a soldier observes that in midday a market is empty. He orients that by knowing that usually around lunchtime the market is very busy. So, and that could mean the deviation from normal could mean that an attack is imminent. So he decides to inform his commander, and he acts on that decision by making a radio call. And the Velox Toolkit, well, I guess, let me back up. The project that I'm working on that's using GIFT is called SMART, the Simulation Monitoring and Reporting Tool. And that uses the Velox Toolkit, which is a government purpose rights toolkit that was developed to build OODA loop systems. So in Velox, we organize knowledge into two graphs: an Observe Orient graph that has the state of the world, and a Decide Act graph for intent. So as observations come in, typically from sensor data, they get pushed into the Observe Orient graph. Then we aggregate and abstract those observations as necessary until we reach some condition of interest. Then the Decide Act graph is informed and planning occurs. So the Decide Act graph models the world in plans and goals. Goals are states of the world that you're trying to achieve, and plans are alternate techniques for achieving those goals. So in the decide phase, plans are decomposed into their sub-goals, and then one or more plans are chosen for each sub-goal. And that continues, starting very abstract on top and getting more and more concrete until you reach a plan that's concrete enough to be acted upon. And typically, once the plan is acted upon, acting upon the plan produces something observable, and then that observation can be fed back into the Observe Orient graph, and then the cycle continues.
Yes,
Right, so
I'd like to jump in and say why this idea is really important. John Boyd was a fighter pilot in World War II, ended up being an acquisition guy, invented the F-16 over the twin-engine F-15, and was the architect of the four-day Desert Shield Gulf War in 1991. What was really important is that was developed when integrated air systems against the Soviet Union were really complex systems. There are ground systems, surface-to-air missiles, bombers, fighters, and so this belief system in the military had developed way before our complex systems that we have in our world today when computers and things migrated. So it's still a powerful idea and still used significantly in many organizations in the business world. Go ahead, Stacy.
okay. So there are currently two versions of SMART. FO Smart or Forward Observer Smart was developed first, and it provides easily accessible individual performance assessment for forward observers conducting adjust fire missions. And because adjust fire missions, a major part of that is communication between the forward observer and the fire direction center. Assessing spoken language is a major part of FO Smart. And then we're currently developing Squad Smart, which includes FO Smart, but it adds a collective training aspect. And that adds the part of the process where either an infantry squad leader or a platoon leader requests indirect fire. So the infantry squad leader or the platoon leader is coordinating with the FO. And so Squad Smart leverages FO Smart. And our intent in these systems is not to replace trainers or to replace any existing high fidelity training environments. Our intent is to allow people to have more students to have additional repetitions to get practice without needing to get access to resources that are hard to get access to, like Call for Fire Trainer, or to have an instructor having to look over their shoulder. So, So in Squad Smart, in our initial scenario, the infantry squad comes under small arms fire. It's reported in ATAC, which is the Android Tactical Assault Kit, and it's an Android app. And then that's how the squad leader or the platoon leader is coordinating with the FO, and the forward observer uses a radio to coordinate with the fire direction center. But in our current system, we are using a legitimate version of ATAC. The real world is simulated by VBS3. The fire direction center is simulated, and the radio communication occurs with a transcriber capability. We are currently using Dragon Naturally Speaking for the speech to text, and then we do some basic natural language processing in our transcriber. And we have an optional real-time grading UI where we show which tasks are go or no-go, and we also give reasoning for that assessment. And then on the SMART project, we have done a very basic integration with GIFT. SMART is a performance assessment system for the most part, more so than a tutor at this point. So we send our performance assessments to GIFT. We get game state from GIFT. But when I sat down and was trying to think about, well, what am I going to present in this venue, I didn't know if that seemed interesting enough. So I tried to think about, so how can we best use Velox and GIFT with the OODA loop? And when I first sat down and started this, I thought I'd be able to maybe divide up the OODA loop and then say GIFT should be responsible for these sections, and then Velox should be responsible for these other sections. But the more I thought about it, that didn't make sense. It seemed like they both have something to contribute in throughout the OODA loop. So they actually, in some ways, they have GIFT and Velox have a lot in common. They're both domain independent. Velox is really good at aggregating and abstracting data, while GIFT, even though it's domain independent, is built around, it's a larger architecture and it's built around training. So it has its pedagogical models. There are things for a training system that are built into GIFT, while Velox can be used for training systems or for, other types of systems as well. So Velox is more general in the fact that the only thing that's built into Velox domain-wise is the OODA loop. But they complement one another. So this slide, and I apologize for being busy, is one idea about how GIFT and Velox could work together in a more ambitious integration than one we currently have in SMART. to try and complement one another throughout the OODA loop. I think the observe phase is relatively straightforward. Velox can be used to develop sensors and then send that data to GIFT. Orient is currently where I think most of the interaction in our smart integration with GIFT occurs, because we are sending performance assessments to GIFT. And those can be combined with performance assessments that it makes sense to do inside of GIFT rather than use SMART as an external assessment engine. Decide is a phase where GIFT seems like it should be the lead because you're deciding on training strategies and GIFT has its pedagogical models. But perhaps Velox plays a role in trying to help implement some of the lower level details. And then ACT is a little bit more straightforward. So it's integration. So they're both, I think, just like observe, both sides play a role. GIFT currently has I know, built-in integration with VBS3. We built Velox. We built systems using Velox that integrate with ATAC. But if there's common use for that, then perhaps some of that should be moved into GIFT. And I think that's something that's important to keep in mind also, is how much of what we're doing has generic usage where it does make sense to move it into GIFT so it is reusable by the GIFT community as a whole.
Yeah, I would add, Stacy, I think this is aspirational at this point. Since our focus as a company is mainly deployed systems, near real-time and real-time systems, so we'll be learning in the wild a little bit with the government as we take on this work.
Yes, without a doubt. This was very notional. And the following is also a notional, I said that on the slide in this case, idea of an example about a more ambitious integration between SMART and GIFT. So SMART currently will detect if an observer, if a photo observer reports observer target direction. And we can detect if they're under fire, assuming that's reported either in chat or as a map icon. And then, so we currently will do performance assessment on the observer target direction. And one thing we're assessing is it correct? But we're also assessing, was it transmitted at the appropriate time in the mission? And was it necessary given the type of a just fire mission? So we'll send that performance assessment to GIFT and we'll update its models based on that. And then in Decide, GIFT could select an instructional strategy, perhaps to provide guided observer target direction repetitions in a less stressful scenario. And then I can imagine the ACT phase being where GIFT modifies the VBS3 scenario while SMART updates the ATAC display. So again, this is a notional, more ambitious integration than what we've done so far, where we'd be doing more, we'd be building the tutoring part of the system in more so than just our current performance assessment.
Yeah, Stacy, I would like to say that it's a little bit more than aspirational here. I mean, we're working with ATAC and real combat systems. I personally have a belief, this would be helpful in training, and we have to get to that first, but one day that systems like this, these intelligent agent systems, will be on handheld devices in heads-up displays for soldiers right at the pointy edge, and helping them with some of these structured type requests that they're normally not trained in, like a call for fire for field artillery, a close air support 9-line brief for a A-10 or F-16, or a CASVAC type situation where you need a medevac 9-line brief and you're under tremendous cognitive load. or maybe you're under fire. So again, that's where we definitely want to push to, but we got to start small as a seedling first.
Ryan, even though the bottom part of this is not currently implemented, there's nothing on the smart side that we don't know how to do here. So it's not here now, but it's something that could be here in the near future if this type of integration makes sense. So any questions?
Yeah, Stacy, this is Greg. Thanks a lot. I thought this was a very good talk, and I think it does raise an important point, which is that I think we can expect, and we've seen different vendors will, for whatever reason, will have expertise or have a customer that wants some kind of specialized assessment built for a specific domain, just exactly like what happened, with FO Smart, where we had the schoolhouse wanted to assess, forward observer and JFO actions for automating assessments. And normally, I think we would build those kinds of things just into a DKF or some other kind of, module or interface. But I think that we should think about the larger problem, which is as we encounter these kinds of assessment tools that may mostly just be built for providing, kind of feedback to a trainee or a trainer, how do we leverage those in an adaptive training framework so that we can then not just say, you got to go, no go on this task, but, use it to really build interactive, adaptive training off of it. So, I think the framework you suggest makes sense, but I think I think it's worth putting a lot of thought into, how do we make a more kind of generalized plug-in for other assessment engines? That's not really a question, but just I think it's something that we definitely should consider over.
I agree.
Oh, go ahead, Stacy.
Oh, no, you go ahead. Sorry.
Oh, no, I just have a comment and then a question on top of that. I think ideally integrating with GIFT is the intent of driving that assessment engine interoperability and having a standard to do so that you're more or less just managing where data goes for what assessment purposes. A question I have with regard to the potential OODA loop collaboration. Do you view an ability to kind of create a self-optimizing system in that capacity, where the OODA loop is also observing and in some sense evaluating the decisions that GIFT would make at the strategy level, so that it can learn what impact it has on shifting an outcome or creating some kind of delta?
That's an interesting thought. That's something that we could definitely build into a system. I hadn't thought of that, but that makes a lot of sense.
So Stacy, this is Joan Johnston. Hi.
Hi.
Yeah, I'm really excited about what you've put together here, because I did a fair amount of research applying this OODA loop model to tactical decision making in teams. And I don't know if I've shared any of those papers with you or not, but if I haven't, I have a bunch of papers I can share. And some of the research that I worked on in the past, focused on developing skills in each of those boxes. So the recognition prime decision making training for the part where you observe and you orient. And then there's the teamwork skills that have to do with planning and executing the decisions that are made to address the tactical problem. So there's quite a bit of really good literature out there that you could leverage to help understand how you might diagnose the performance within each of those major categories, and then using GIFT, to make to make decisions about the kind of training that might be focused on the observe and orient piece and critical thinking, and then the parts that have to do with teamwork. So, I can certainly share more with you. Thanks.
Sure, thank you.
Yeah, I was going to say, Stacy, this is John. I think GIFT adds an awful lot of meat to the bone for the OODA, because particularly in the Army domain, the conceptual situation in combat, especially asymmetric warfare, is complex and difficult. So I like a lot of these ideas that were expressed.
Yeah, I agree. I went into this not trying to say I had answers to anything, but trying to put something that would cause discussion. And I'm very happy with the feedback. I agree. I appreciate all the feedback.
Okay, so we still have a little bit of time. Is there any other questions or comments?
Stacy, this is Bob McCorney. I'm curious how you would characterize the complexity of the OODA loop for the judgments and the decisions that people were making. I'm saying this relative to Greg's comment that there should be some, or there might be some higher level representation of the world around the trainee that can be represented in a standard way as much as possible.
Right, and I think so. If trying to go ahead and build what Greg described, I think the first step would be to understand what things do we need to know, what data do we need to capture. So we can know from the time, I guess, so if GIFT recommends a strategy, we could observe the fact that that strategy was recommended, and then capture the appropriate data at that point. That we'll see how things change. So maybe I think a lot of this is going to be domain dependent, but maybe so let me go back to my example where GIFT made the recommendation to provide guided OT direction repetitions in a less stressful environment. So maybe at that point, we determine that they are actually giving the correct OT direction. So that's after that strategy change. That will be one thing we can determine. And then if they go back to a more complicated strategy, track that data. I don't necessarily think there is a one-size-fits-all solution to this. I think we'll have to think about the individual problems, see what will be useful for people to know, then model that.
Hey, Bob, this is John. I would just like to add, and I think we got some of this when we did the metrics project with you together. The second and third order effects, the OODA loop's really good for the domain where you got to make a good decision really, really quick. But a lot of things like strategy plans are things you don't do quickly. It takes a long time to put together. So the second and third order effects are good places to integrate the GIFT framework, in my humble opinion.
Okay, thanks.
Any other, even just thinking about this, like I think, GIFT somewhat naturally fits within the OODA loop kind of mindset, at least from a autonomous system perspective, I would say. From an observation standpoint, the idea is to consume as much relevant data as possible, and we use various triggers and events in the environment to orient the understanding around those observations. And then from there, it's a matter of deciding what to do within the context of that performance and then acting on it. I think there's something to kind of build off of and to identify those intersections with the Velox tool. I'm excited to see where this goes. Anything else out there? Okay, so we're 7 minutes ahead of schedule, so I'm gonna kind of throw out a spontaneous 7-minute break, and we'll come back at 1:30 just so that we can stay on schedule and allow folks who are coming and going to keep up with our pace. All right, thanks. Okay. So we are back. It's 1:32. So just like that, we're behind schedule. I'd like to welcome our next speaker, Farouk Ahmed. I believe he comes out of University of Memphis as well. Farouk, are you ready?
Yeah.
All right. So 25 minutes. We'll give you a 5-minute warning and take it away.
All right. Do you see my screen?
Yep, we can see it now.
Can you hear me also? Well?
Yep.
All right. Okay. So, welcome all of you to our presentation, paper titled Towards a Gift-Enabled 3A Learning Environment. I am Farouk Ahmed, and I have Keith Shubek and Professor Shinyan, who is an important contributors. So the 3A here we're referring to as the content awareness, context awareness, and user awareness. Content is about the learner, whatever content they are interested in. Context is the surrounding of the learner, and user awareness we are referring to as the emotions of the learner while they are learning something through the learning environment. So in this work, we're mainly focusing on the user awareness, and it is basically using existing technologies to make it work with the IKSs, like the face recognition, emotion recognition. These are already existing technologies. So we are using those, integrating with the intelligent learning systems. So two things: monitoring the individual emotions and putting those into the intelligent system to work. And it has to be cheap also. So how to do that? One way is to use the GIFT monitor module or GIFT sensor module. So in this case, we use a GIFT monitor module. So GIFT looks for the camera webcam from the learner machine and get the facial expression and classify emotion from there. So existing GIFT uses YoCam. It works very well, but sometimes for some users configuring is a little bit hard. So this way GIFT can monitor learners and store the information, metadata. We want to make the emotion detection technology very easy to use and pluggable. If we have centralized location mechanism to capture the emotion, that will be great. So here is what we have done. So we built a class in emotion, in the GIFT monitor module to detect emotion, recompile it, and put the jar file and ask people to configure the YoCam. We also did some port forwarding there and then capture this. So on the left hand side, there were multiple cameras. So we configured two users, multiple camera, multiple faces. On the right hand side, one camera with an artificial face and the real face. So that actually tells us that it can be used in a classroom environment also with multiple users. So we used another way also. We explored another way, which is this. So we implement a JavaScript version of that, and the emotion classification happens in the learner's machine and store those data into the learning record store. So this is a possibility that the GIFT can retrieve or query those data from the learning record store. And these data we captured every 3 seconds and stored into the store. So this happens in the user machine. That's why it is distributed. And no configuration or minimal configuration needed. If there is a webcam available in the learner's computer, it is automatically found and it starts detecting the emotion. So this is a screenshot of the JavaScript version of the emotion detection. So basically we are producing an engineering solution which is very cheap, using existing technologies, using cloud. As far as I know, that have not been done before in the GIFT environment. So we are using also the intelligent tutoring system. So therefore, the data is individualized. If a user is logged in, and the camera will look at the data of that person. So if I'm logged in, it will look at me, my emotion. There are some emotions like currently it returns 8 different generic information. Some of those emotions may not be related to learning, like angry or fear. So, but at least something is working, so we can work on finding out the emotions related to learning. This is a screenshot from the learning record store. And for every instant, there are 8 dimensions, but we calculate some more dimension also, like the sum of the square and some of the individual confidence score of an emotion and cumulative score and the number of the instance and the z-value. So these are the information stored into the learning record store, and that actually gives us a baseline for a certain emotion over time. And when you talk about the 3 A's and this awareness, the A's are individualized awareness. We already mentioned before that every 3 seconds, 40 number and 8 type. So total 48 data entry is stored. So, and the Z values are also there. So this is that screen. So we integrated that JavaScript version with the intelligent tutor, the ITS, and we saw that it works. And basically here is a question may arise related to the privacy. So basically any user, when he or she is logged in, this is his or her emotion. This on the bottom side, if you see the confused, surprised, and happy, this is actually being shown where the Z value is above the 95 percentile. The Z score is more than the threshold value. So any user is looking at his or her own emotion, and the face is also not shown here because of the privacy. And when we store the data, we are not storing any facial image, just the numbers, confidence score, and the calculated sum square, and the standard deviation. Those are the values we are storing. So what we can do with this, we can do actually many possible and probable things. Like this, if we know the emotion of a person during his learning, it can probably contribute to the improving the adaptive instructional system. Or we may capture categorical emotions, for example, while answering questions. Or we can enable the geolocations also, or we can make it responsive with a responsive design, easily runnable in a cell phone. And what we want is we want to answer the research question as a researcher from this data. And what we need is that a economical and ethic-enabled application which works, a system which works sufficiently to grab metadata about the user, and this is one of those examples. So currently there is a limitation is that some emotions are generic. I mean, all the emotions are generic and some emotions are not related to learning. And basically here we are using the AWS recognition just to get our hands dirty. We can train our own model and make it work. So this is just an example analysis, and I took it from the real data, and I just plot the G values, and after plotting I see that this black line is confused, and the purple one is surprised. So this may be related to the learning, and those has like more variations, and others like calm, happy, fear, those are having less variations. We may need to do more analysis to predict something on this. So now I would like to show the demo, and let me bring up I already started the instances and started the YoCam. So the first one I will show you the gift monitor version, which I have to click a button. This is actually the YoCam I configured with another camera in my computer. So I did not enable continuous emotion detection, but so that's how it works.
We can only see your slides. You might have to share your entire screen.
Oh, okay. Let me do it. Okay. Do you see now?
Yes.
Okay. Because I plugged in my I added my camera twice. So both times it found me as calm. So this is one of the implementation inside the gift, and another one is in here. I'll show you the JavaScript version. So this is the JavaScript version, and this is being loaded. So I enable the camera. Actually, I need to turn off. I need to unshare my camera and then okay. Okay. Yeah, so at the bottom, if you see that started recognizing, and what it does is that it pulls the last record and add on top of that. So, and if we go to the learning record store, so these are the records just stored right now. So in the, if you see the data, so these are the data it is storing, the type and the values, different values. These are being stored. Okay, so let me go back to the presentation. And basically that's all from my side, and now I'm open for any question and discussion.
So I think that this is really terrific work. And you know, if you look over in the chat, we're discussing your work in a number of different statements, right? And this is one of the things that was asked for out of last GIFTSym's requirement set. And I put you in contact via email with Noboru Matsada of North Carolina State University, because this is one of the things that they were looking for in order to conduct their experiments. Good stuff. Fantastic presentation, great demo, good work.
Yeah.
Thank you.
Can I add a comment? Or
yes, please.
Not a real question. If you know, in our talk, we really missed this component about the effective dimension of the learner model. So if we really wanted to add on your feature for this emotion detection, just the camera now, how soon do you think this can put into work? How much is the learning curve to how to use your tool and then add on to our learner model?
It's actually within few seconds you can do that.
That's
See,
that answer. Okay.
Yeah. What happened is there was we just separately just almost like an add-on, like a one JavaScript file. And then, of course, you need to have an Amazon, whatever trial kind of license to use their recognition engine. And then after that, and then you just specify LIS, because we actually create a simple JavaScript to fetch the most recent emotional statement from Learning Record Store. Now, each of the statement, remember, we have like 48 numbers. Those are our computation for the mean standard deviation of the history. So use that one to really compute the specific learner at any given time, how much each one of those measures are deviate from your norm. So we actually do, for most of the time, this specific emotion classification classify almost everything as calm, because calm is dominant kind of thing. But yeah, but in this case, we actually can look at the deviate of even your tiny surprise kind of feature that is above the 2 standard deviation of your norm. We classify you actually surprised.
How about the boring?
Yeah, well, see, as Farouk was mentioned about right now, we use this Amazon kind of thing. It may not be learning kind of relevant kind of emotion, but we need to actually create our own kind of engine, classify only for those that are learning relevant.
I think that's a very good project or extend the project for my data mining class. Especially the deep learning class, we are just getting into the CNN, the convolutional neural network, and make our own. By the way, if you go to Amazon, is that a free or not a free?
It's a free to a certain extent, I think.
Yeah, those are usually they'll not be massive, but
yeah, but you realize Amazon probably wants you to do that for free because they're collecting a lot of faces. Whatever your contribution is actually,
your data, yes.
Yeah, in other words, right now, we do not, in our interface, we only capture the vectors. We're not really showing, having the face in our system. But since we're sending the face to Amazon, then Amazon have the faces. Well, that's what Amazon, we use crowdsourcing to train their classifications, right? Now, if we have our own, then we may need to consider others, but Amazon is doing that all the time.
Oh, great! That's anyway. Start the one way and then the other. Whereas make the emotion detection is not an easy job actually.
Well, actually, what we have as Farouk was talking about, technology is there. If you spend a lot of money, you can do it. Right now, it's like one JavaScript, one connection, and one learning record store kind of connection. You can have it every 3 seconds, and you can have a moving average. You can draw your emotional kind of swing in any given time.
Oh, that's great. That's definitely a good add-in feature for our course, because we really think it's a big job, but now you can have a solution already. Thank you very much. It's a great job.
This is Ben. How do you envision applying your long-term view of affect as stored in the learner record store? Like if a new learning exercise is initiated and you're able to pull data from that LRS to view their prior experience.
Yeah. So Farouk, can you show the learning record store? The one here. So the trick is you only need to retrieve one record. You do not have to retrieve all the record. Remember, the mean standard deviation, they have a computational formula. It's incremental. You do not have to have a million record in order to find the mean. You do not have to have the million record in order to find the standard deviation. All those ones, sum of squares, sum of x, those two numbers plus n, it's enough to compute your standard deviation and mean and z-score, okay? That's why this is very, very efficient. So every time, here, the total n equals 73, and then if you go in next one, it's going to cut to the 74. All the data saved is actually contain all the information you have in the history. So you do not have to have all the record. Before, one say, "Oh, I want to have a history." Well, think about it. You have million, hundreds of records. But this way, we made a way you save the information or save the summary statistics, and then make the next computation is incremental. Am I answer your question?
That makes sense.
Yeah, this way every time, for example, if you run a game, then it's going to be identify Farouk and his emotion, and then add in the total number, and then get the sum of squares and the sum of x, and then compute the z value for the current emotion. Of course, in this case, we have a 3 kind of moving average, instead of instantly kind of change. So that way we actually make it emotion smooth. That's what we call the smooth parameter, to make it a smooth. Okay. So I'm not sure what I answered Ben's question, but that's what we find the efficiency of this. So it's getting in real time.
In some respects, it was more of a how do you use that to inform a pedagogical decision, or how does the system react to that data?
Yes. So right now, what the Farouk is an engineering student. We're trying to build an instrument. We give you a measure. How likely? It's almost like I build a blood pressure measure for a doctor. Doctor will use it, whatever purpose they want to use. So in other words, we provide this one to learning scientists. So learning scientists decide how to use this emotion. It need to be correlated with the questions, so on and so forth. So one of the questions that I was going to ask Anne when she was looking at the survey tool, we actually can associate this one with every survey question. So when you are asking a survey question, actually I want to record the emotion. Whether the question is really out, surprise or something like that. So that's what you want to correlate what you have emotional, you observed with the specific learning content. So that's the idea of 3A. Those 3 A's need to be combined. Okay. The learner aware, that's what Farouk was talking about, and then you have context aware and also content aware. So that's the 3 aware kind of thing need to be integrated to really inform a learning, a pedagogically learning, pedagogically sound instructions.
Very cool.
Okay.
Any other questions? Okay, thank you very much.
Okay, thank you, Farouk.
Right, thank you.
So I believe that brings us into our final break for the day. We'll reconvene in 30 minutes at 2:30 p.m. Eastern Daylight Savings Time. And then we'll round it out. We have 3 talks left by Ben, and Bob. So stay tuned. Hey,
Battle of the Bens.
Ben. Hey, Ben. Did you see that what Farouk did?
Yeah, I saw this.
Okay. One. Yeah, it's very simple. Just 2 JavaScript that takes care of that.
Yeah, it's great. Yeah, I'd be curious to go over and see more of that. So.
Yeah, you can try. We can send you a link. By the way, anybody interested in this one, feel free to send either me or Farouk email. Then we would love to also to train our classification too. So just like, but we're not capture your face. Your face is sent to Amazon. We're not capturing your face.
Yeah, and good to go over it. Good to see Farouk. I haven't seen him in a long time. Summer just started.
Good to see you, Ben.
Okay, well, I guess I'll see people after the break.
Yeah.
Can I ask one question?
Yes, sir.
Hello?
Yes.
Dr. Who?
Oh,
Dr. Who?
Okay. Sure. We're just hanging out here, right?
Yeah.
Yeah. Can I ask one question? So, is this technique only used to detect the emotion on time, or can this technique can be used to detect the emotions in the videos?
Well, this one, what happened is you just take instantaneous kind of picture and send it in. So that's the reason we have this moving average. So in other words, every 3 seconds we take a picture and send to Amazon, and Amazon come back. Okay, when Amazon that coming back, we use historical data to compute the z values. Actually, 8 z values. Okay, but that sometimes it's not very stable. So for example, if you want to detect happy, if you have a sudden happy face, doesn't mean that you are happy. So we actually computing the moving average. For example, if you have like a 3 consecutive time that classified you as a happy face, and also all up there, like a greater than the 2 standard deviation of your normal face for that happiness, then we can label as happy. Now that 3 is a choice, but we're very random. If we want to make it longer, we can make it like a 4 or 5, right? So that's, if you really consider that motion, because it is motion, by taking the every 3 seconds, okay? But it's not motion because it's a static image sent to Amazon, right? So in other words, then we want to make it like a more considering a period of time of emotion, not the instantaneous emotion when you take the picture.
Okay. Okay, right. So how many category now? How many classification at this moment?
There's 8. There's 8.
8.
Yes, 8.
8 and how many of the, actually I posted one question in the chat box, and how many of them are the epistemic emotion?
Probably none. Probably none. See, what we have is, since we're not building the emotion classification kind of engine, we just use. So if you end up having something that the epistemologically relevant emotion, that's great. We just use your server, because this one is, we just take whatever emotional classification you have, we make it. Yeah, so ideally, then, as we mentioned, if you have a learning relevant kind of emotion classification, we would more than happy to use that.
Okay, so basically we can also training our own classification.
That's
understand, right?
Yeah, exactly. So in other words, so in this case, we only train that for example, when we bring back your emotional, kind of vector, or that vector, only consider you regard, it doesn't matter what kind of courses you learn. So eventually we're going to say, well, geez, your curve for learning mathematics may be different from your curve learning history. Okay, so when I judge you learning history, your happy face may not be the happy face because you're happy all the time when you learning history. Okay, so that need to be normalized as. That's why we have the 3A. The content. Okay, a content aware and a context aware. Okay, so it's always compared with your norm. So that was the three things need to be considered together. Right now, the reason we say this is towards this 3A environment, because we have the very, very inexpensive solution to detect the face, detect the emotion, and that can be easily used. So the remaining things, how do you fine tune this experiment? What kind of normalizing kind of curve that you want to check against? That is up to the implementation.
Right. Thanks so much.
Yeah, Cheng-Yen, I didn't catch all of this, but I know when I look at this kind of data, one thing that I would probably do initially is you kind of mentioned averaging. I would probably have something that would be like an exponential update function or something like that. That would give you somewhat of a smooth value. Yes. That kind of, basically, and because you do the exponential updates, it essentially already downplays the older data and upplays the more recent data, but doesn't entirely discard the old data too.
Yeah, this one actually not. So I use basically, I only consider that, let's say we assume the emotion is normally distributed. Okay. Therefore, every record I have, it's storing the sum of squares and also summation of the x. Those two numbers you can use to compute the mean and the standard deviation with the n.
Oh yeah, you can, but I'm just saying in terms of smoothing that, because what you're going to end up with is a bunch of point estimates that will have essentially you'll know the new one, you'll have the kind of the jitter. I'm saying from that, you could go over and apply a function that essentially gets you an exponential update function is basically just, it's basically a different type of average. It's just a front weighted, I mean, you can do it an even average, but in this case, we're talking a front weighted average.
Yes. So we call the smoothing kind of algorithm, but in this case, it's average, but we should have a weighted average.
Yeah, well, I mean, that's what I was saying. Go over and look up the exponential weighted update functions. I've found those actually be really nice because they're wildly fast to compute, because all they really are is, one number, basically constant times x plus 1 minus constant plus whatever the new value is. And you can tune that constant to sort of
look like a convex combination of two numbers.
Exactly. And so basically that can be anything from a straight average to basically just taking the most recent value. And kind of by tuning that, you could probably get something that would be about at the time scale that you care about for emotions that would give you something there. And that might be a useful it might actually be a little more valuable than having a moving window. I've done the moving windows before, but it actually takes more calculation to do the moving windows, and I don't think the moving windows are necessarily better.
Okay, well, that's good. Good suggestion. Right now, we basically take the three, take the three measures, and then just average them. And if we use yours, you said you only two.
Well, yeah, that's the thing. You can go over and update, because what you do is you basically have an accumulated value that's your kind of current value, and then you have your new observation, and just basically average in your new observation with a weight every time. And so it's really fast.
Okay, well, that's good. Good to have a different kind of smoothing function, or
So it's something to look at. It's one of those ones. It's not the smartest smoothing function, but it turns out it's really useful and really quick. So I tend to like it.
Okay, well, that's good to know, because once you start it, every 3 seconds you have one. So after a minute, you actually have enough data to really do whatever smoothing or weighting functions you have.
Yeah.
Dr. Hu?
Yeah.
I have a very nice application. Really need that piece. When I'm doing the team collaborative learning modeling, and we are only limited to the text language. The text language itself cannot tell the students are just joking or truly angry, because we want to detect the emotion or identify the bullies or dominating or passive or those kind of emotions.
Yeah.
So when you combine the text message, that's the context, and the content could be, what they say, with the emotion, that will be really give a good improvement of the estimate of a student emotion, the affective dimension of this teamwork.
Yeah.
So
I think right now that this can be easily used, even with the labeling, like something like this. We always can remap to our own kind of learning relevant kind of dimensions, because emotions. Basically, those are just 8 numbers, and they just simply to have something. So we always can map them to our own purpose. So alternative idea is, instead of train your own engine, just use as much as possible whatever vector they have, and then just apply our own. So that's something that again is a cheap solution. You really do not have to train another face recognition. If somebody give you a very good vector of the face description, you just use that 8 numbers.
That's explain exactly the difference between face-to-face meeting. When I'm there, I can see who is angry. When you say the same words, but without that emotion tag, you cannot say this is joke or it's really angry. You pick a few bad words. Those bad words could be a joke, but it could be angry. that piece we're gonna really switch between the two. I think.
So one thing that we want to do immediately, actually, I was talking to my student that we can use this one to combine with the survey. So survey, we have like 24 of questions to ask, and you ask simple questions or deep reading questions. We always assume some of those questions are deep and hard to answer. Well, when we ask them, see how the learners' faces look like, and then the gift like a survey tool already have them. They actually can, because those of you that did not play with the survey tool is much more powerful than what you use in Cortex or others. Okay, because there are a lot of detailed markings and labels for each of the questions, each of the choices. Okay, so that's going to be linked to the emotion that we can actually looking at how to ask questions and what are those questions that most on topic, on target for the learner.
That's a great add on.
Yeah.
Oh, that's great. Thank you.
All right.
Okay, welcome back from the break. The clock just struck 2:30 within our time zone, so we have 3 remaining talks. Excited to round out the day. They should be excellent. We're going to start with Dr. Ben Nye of the Institute for Creative Technologies. Ben, do you want to go ahead and share your screen?
Yeah, so I'll go over and I'll share away.
So 25 minutes, and we'll give you, if you hear a bell in the background, that's a 5-minute warning.
Okay, so you're not going to feed me when the bell goes off. I see that.
That's right. There's slight conditioning going on.
So I'm going to present here on some work that's still we're still kind of sifting through the data. It's ongoing, but we've done the study that collects the data and done the integration. So it'll be more on the design portions and kind of the approach I've been using. So as you might guess from the title, the goal is to integrate an engagement classification pipeline that we developed into a GIFT cybersecurity module. So overall, when my group at ICT is looking at learning analytics, our big high-level objectives are really about actionable AI and machine learning. And particular problems that we're interested in the algorithm side is how to make better predictions with less data or cost. I see a lot of problems that have like kind of cold start issues. So we're very interested in cold start problem. Another one is human factors, obviously what metrics help humans train better. And the last one is sort of process and prototypes. How do we actually combine these things so that we can see benefits for users? So kind of making the prototypes and then eventually studying them with people. So we're interested in this. This work that we've been doing over the last couple of years here at ICT is really about engagement. We think of engagement as basically action where you make a psychological investment in learning with heightened concentration and interest over a time period. And we care about that. Obviously, if you have lack of engagement, you tend to have lower learning. And if your engagement is poor, you also tend to be more likely to drop out or have attrition. And so obviously one of the big things is that engagement can be induced, so it's actionable. So it is a worthy problem to focus on. And so the overall approach is we wanted to make a service that we could basically plug into multiple different platforms. And over the course of a couple of years, we plugged into 3 separate platforms with this framework that we put together. And the goal is basically to ultimately kind of be getting reports and metrics out of there on multiple different systems for this. So basically, the challenges that you really have in these things as you move to a new system is in a new system, you don't really know what normal looks like or what engaged looks like. And so if you don't know very much about it, it's hard to get inferences about activities or systems that it hasn't really gathered a lot of information. And is there a way that we can kind of reduce the amount of human labor that gets us to that point? So how much can we do just kind of automated with annotation versus actually having to have humans go in there and manually do things? So this was inspired by some work that we actually did a couple of years ago looking at engagement, multimodal engagement system called Lite, which had a character there and there's publication on it. And so we looked at engagement from a lot of different angles, and we got there. And the question that we had for ourselves, a lot of people was like, okay, great, you got these, but and you found something about this system, but how would you do that for a new system? Would you have to build everything anew and kind of hand do everything? And it's like, well, yeah, it makes sense to see what we could generalize and reuse. And so the approach that we decided was a good one was to try to look at really a semi-supervised learning approach. A semi-supervised means essentially that some of your data is labeled and usually a lot of it is not labeled. So you're trying to have a small amount of labeled data and then use that with a larger amount of unlabeled data. So you can think about it as being, having elements of both, clustering and classification kind of working together. So a typical, way that you can do this, you can use like an active learning type approach, where you can essentially have some labeled data You train your model, you're querying some data to basically use some of your unlabeled data that you have, trying to select your samples, annotate samples of some mechanism, then add them and retrain as you grow. And so you can see that where this also kind of works as new data rolls in, you can basically take the new data and pipe it into a model in this respect. So we made a framework called the SMARTY framework, a service for measuring and adapting to real-time engagement is the acronym there. And so the first thing we start is basically XAPI logs, so standard-based logs. So we assume that we have two types of logs here. One is user logs, real user data, which we assume we have more, and we assume it keeps getting bigger. The other approach that we take, however, is we take playtest logs. So there's been a good number of different ways we say, how do you know who's engaged? Like, well, you run a study and you watch the people engaged and do the BROMP protocol and, have humans hand annotate what these people's emotions were. Or you go over and you do self-report and you have them, capture the self-report data and you kind of disrupt their experience a little. And so what they may or may not be honest, or they may not pay attention. They may not be. It's also, if they're not engaged in your system, why would they be engaged in your surveys? There's, these things aren't even disentangled from each other. So we actually thought of a good way to get your initial labeled data for engagement was actually playtesters. You essentially know, some real like player personas almost about people who are going to engage in a system based upon their motivations and their likely behaviors. They're really trying to learn this thing, very detailed. They're going to be diligent. They're going to take a little more time with things. They're going to try to get it right. If they, on the other hand, are basically somebody who already is kind of an expert in this, they're going to be faster and they're going to be good. On the other hand, if they really don't care about this stuff and they're just trying to check the box, they often will be fast. They might race through the material. They don't really care if their score is not very good, as long as it's enough to have them check that box. Likewise, they might be distracted, is another way they might be disengaged, where they essentially will have long delays or long pauses. They'll have really irregular times. Their time working on tasks may not be very correlated with their scores on the task. And so kind of these different patterns that I would say are fairly general patterns, I think. But moreover, if you get someone to sort of act out these motivations of how they're trying to go through the system, then you'll see how they would go through that. And you can use basically people who are just instructed to do that. So that's the approach that we're taking overall. And so it's important to kind of recognize that for understanding how some of the rest of the stuff works. And so both of those are generated by the learning system. So at no point in time is someone actually labeling the data. The labels come from telling the person that you are racing through the system, trying to get through, not bomb it, but you want to just get through this thing fast. You don't care if you don't do very well. So then basically we have, the logs come out and we have a converter, or we just have a direct API for logging, which we can plug into a system. That gives us our raw XAPI logs. Then for any system, we generally have a system-specific cleaner, because some logs, often have some just issues or bugs. Maybe the system crashed, they didn't terminate. You want to have some recovery of those. That happens, reasonably automatedly once the cleaner's in place. You have then what I would say canonical XAPI statements. These are the ones that we rely on as being complete. So, session start and the end, etc. So then from there, we generate raw metrics. Some of the raw metrics that we find most valuable, kind of our core ones, are response time, how long they're taking to act and start giving responses or do steps, scores, how well they're doing on things, duration, how long they're spending on things, individual steps. So, you can say that they did more actions versus less actions and things like that, even if across systems you didn't know specifically what the actions meant. So from there, we get intermediate metrics. We can get things like task difficulty, task attempt bins. So they attempted a task, what was their response time versus their score versus the difficulty of the task, and analyze with that. And then from there, we generate a feature set. We can generate different feature sets, but those are kind of some of the ones we've been looking at, the intermediate metrics mostly, and raw metrics coming in there. And then we basically have our real users and our playtest archetypes. We cluster the real users, we get alignment labels to the playtest archetypes, and then we use some sampling to get us our classification. So what does this kind of look like in practice? You can imagine that if you have the A's, the C's, and the B's in this graph were your basically data that you had from your archetypes, and then the little clusters in there of points where the raw user stuff they don't know much about. You can basically say, okay, I did this sort of bottom-up clustering, and then I did this. I had these archetypes, and I'm looking at these things, and I can actually match one to another. Right now, we're using basically centroids, so we're basically trying to find the optimal matching of the centroids of these things to try to find which clusters align with which labeled points. And so we found reasonable results there. You could do it a little bit smarter and have actually every point-to-point thing, but the centroids, as data accumulates, tend to be pretty good. And our experience with this on the Elite system, which is the first one you applied to, essentially indicates you don't need that many archetype points. We're talking about 4 or 5 per cluster before you start getting a reasonable idea for the stuff that we were looking at for those systems. So basically, you got your labeled archetypes. You're aligning them to your unlabeled clusters. You then basically can take essentially labeled data and a sample of that unlabeled thing. You don't have to use all of it. There's reasons why you might not use all of it. Overall, one of the tricks is you don't really trust either one. One of them is basically people pretending to be like a user, which can have some bias in one direction. The other one is that you don't really trust the user data because it's incomplete. You don't have a ton of it, and you are using kind of bottom-up clustering, which may not give you exactly what you want. So there is kind of a balance about how you want to mix that data long-term, which we're looking at, but we don't have. If we had the answer, we give it to you, but it may depend on specific systems. One thing that we did find systematically is that the labeled archetypes tend to be more extreme than the clusters. Which is that someone who's racing as an archetype tends to be racing more than the average racer in a cluster would be. And that's just something to be aware of, that when people act things, they'll tend to use that strategy very consistently, whereas a real person might only use that strategy some of the time. So people will actually technically we're classifying them as if their whole session is like that, but actually it might make more sense long-term to classify, at a more granular level, because they're potentially switching in and out of these at different times. And this is a nice thing because it allows us to go and keep what I would say the data costs for collecting data low. Essentially, the high data costs are like a pedagogical expert, somebody who's going to go and, trained annotators, reliable, reviewing data. Like that's really quite expensive. The next one down is expert users. If you want to get people who are going to play those expert roles properly, they are still expensive because they're at least trained people. Novice users are super easy to find. You could go over and get people to go over and do that like a regular user very easily, cheaply. I mean, we use interns and anybody that we could find handy to go over and do some of those archetype data. And then the target users actually, they were going to use the system anyways. So basically, in the worst case, you're collecting that data and you just can't go over and use some of your metrics or things like that until you get up to a critical mass. So we found for Elite that this process is actually pretty useful. So when we looked at basically like clustering and alignment, just kind of using cluster and align only with no classification, it does certainly do better than chance if you think about having all the data. So this is clustering sort of matching itself against clustering and saying if you had a data point that if with all the data you had, in this case about 140 points, would you have got that in the same cluster if you clustered earlier and then did the alignment? And it turns out the answer is kind of yes, but it's super noisy. I mean, this is, we've got 5 clusters and our error bars are like two clusters wide. It's huge. And likewise, points don't tend to stick in the same cluster either, so they tend to jump around. So it turns out just doing a straight cluster and then we align it is not very useful. On the other hand, if we basically pipe these things in and do some sampling, or even without sampling, and put it into a classifier together, we kind of mix the data, then we find something that I would say is quite stable. That basically by about, in this case, there was about 20 odd sort of labeled archetype points from player, play testing, and then by about 40 essentially unlabeled, we start getting very consistent with what we have, another 100 unlabeled. So that was very, very promising on that. But that was only on one data set. So we said, well, the next thing to do is try another data set. And that data set is the one that we collected with the GIFT cybersecurity mini course. So how do we integrate with GIFT? So we had done some prior work with GIFT on some work called the multi-agent architecture, which basically is a module in there. It's a different type of module that, unlike the the pedagogy module or the domain module, they had the agent container module. The agent container module is basically a module that's just meant to specify and hold other modules. So if you specify basically, oh, I want this service to live in here, then the agent container can monitor things and then dispatch messages to other ad hoc services that you wanted. In our case, the service that we wanted was a converter from GIFT messages to XAPI logs that would sort of sniff out the types of things that happen in a course and transmit them. So we added that in, and it was registered for the course that we wanted to use it for. Because the agent container, you can specify what things you want to include in what course. So from there, it did essentially the things that I had specified earlier: the raw logs, the canonical ones. We get the benchmarks from our archetypes. We get our individual metrics, and then we get our classifier. So the mini course that we developed, we basically just did a really quick 2-module mini course, something that someone could definitely do in an hour, even if they spent pretty good focus on it. And basically a total of 12 activities in there. And so what we had was basically phishing, which we made kind of lighter, potentially more engaging, and HTTPS and how that protocols and how that worked, which was kind of a drier one. And those modules were basically completely mirrors of each other in terms of content, with a text introduction, then a video overview for like a YouTube video, some basic questions, so 3 simpler multiple choice questions, intermediate questions, 3 harder multiple choice questions, 1 external URL web page that basically would, multimedia web page, and then a dialogue-based assessment. So they would go through the phishing one, and then they would go through the HTTPS one. So this is the overall structure of that course. We had some surveys before and ahead about their initial experience in those particular modules and in cybersecurity in general, and also their interest as a proxy for their engagement in there for pre and post. So to give an idea of what we mean by like lighter versus drier. Essentially, what we have here is on the left is the phishing. So we have a nice Wired article, which is 3 golden rules. And basically, for an external URL, on the other hand, we have for the HTTPS is basically Robert Heaton's. I think it's actually a quite good summary of HTTPS, but I mean it's a pretty long page, and it's it's technical. It's got some jargon in there. And likewise, you can even see it in the dialogue assessments that we have. So for the phishing one, we have things that are much more sort of scenario focused. Basically like, oh, okay, I should not be clicking this text that I haven't seen in email, versus having to regurgitate how basically certificate authority should be working. So working on this, we collected 17 archetype data points. The points that we were interested in the lead and the points that are interested in this one, we can always pick different archetypes. The archetypes aren't fixed, it's just what we want to instruct people to do. But in this case, we were focused on 5 archetypes. And we collected archetype data points for diligent, distracted, racing, and expert. So basically, where experts are people who do things good and well, and you can imagine those as being sort of aligned to 4 quadrants of a likely sort of performance versus response time, though there's other factors as well. The last one, actually, for the 5th one is actually average, just kind of typical person. It's like basically that they're just kind of going through it at a not overly diligent, but they're not, completely slacking or unengaged either. And we do, that one gets classified just by seeing which one doesn't get aligned closely by anything else. We could collect data on that, but it's kind of hard to ask people to act naturally. It's easier to give them these kind of more extreme motivations. We did a study. We collected 100 real user data points that we have now, that we did in the winter. And we also got their pre-post interest and confidence experience in the topic. And so just as a sort of sneak peek at the data, what the bottom-up clustering looks like, which is not entirely what the supervised classifier would necessarily spit out, depending on how we're sort of subsampling these points. But you do kind of see some of these patterns where there are some people, you know, those green dots really do feel like a racing type thing. Their performance is not very good and they're very fast. You also see a fairly tight cluster of basically these blue guys up here that do quite well despite being fast. That's fairly, you know, we got to see what those guys' experience level is. And then you see some things with the orange. I think the orange goes a little high for what I would generally have expected. This was k-means. We kind of been looking between k-means and GMM. GMM, I think, might give a more conservative thing and not get that top portions the way it works for a Gaussian mixture model. But we are seeing basically that these ones do have kind of the more time. We have kind of a big average blob. And we have some folks who are spending a little more time getting a little better performance. So that's you know, some of the early results that we have on this. So I mean, the conclusions on here, I was actually very pleased with the integration. We got this integration done, you know, fairly efficiently, if not too long over the fall, in getting this there as we were setting up for the study. People completed that. We really didn't have much data loss, which actually, you know, for making sort of a new integration, it's not uncommon to have some issues now and again where, you know, certain runs didn't go. Like we looked at the data and it's actually very surprising that at least initially we haven't seen any data points that clearly had to be thrown out. So pretty robust in that respect. So we get the logs processed into viable metrics. We can do the basic clustering. We need to dig in there a little more. And the clusters positionings, you know, give us kind of some stuff with Elite. Elite actually gave us something that actually kind of followed a little more of a curve. This one's a little more irregular, but I think that's it may be just due to the level of variation in the activities, and that's just kind of the high level reaction time versus performance. At the individual task level, we'd be seeing much more granular stuff, and we're showing that. So classification research ongoing. A big thing that we're trying to do here for classification research is I think someone might be making lunch with themselves. I hear many pots. Classification research is ongoing. What we did for, as you kind of noticed some of those graphs about sort of slowly adding the unlabeled data points and then kind of redoing the analysis as if this was all the data that we had. We want to do one of those for this to try to see at what point in time we're essentially agreeing with what we would think was happening if we had the maximum amount of data, as opposed to just the minimum amount of data. So essentially, you know, for about every five additional data points, you want to see how much we're converging towards what we'd have with more data, because that tells us our cold start performance. Like for the Elite one, I could say by the time we had about those 20 labeled points and about 40 unlabeled points, we're getting stuff that if we classified in, you know, a random person, we'd likely be getting them about in the same thing we'd be classifying if they had 100 data points with that kind of approach. Whereas in this, we don't know that yet. It's a little noisier, it looks like, so we'll just have to see. And we also want to be able to analyze the classification threads versus their self-reported expertise and engagement, their interest, kind of pre-post. And so that's the overall. I'm just about on the mark, 1 minute early. So who'd have thought? So yeah, happy to go over and open up for comments and questions.
Ben, this is Bob Sattler. How you doing?
Hey, Bob.
Hey. So question for you about the agent module. So you have information coming from Gift into that module. Can you talk a little bit more about the information or actions that the agent is taking and pushing the other way back into Gift in terms of like remediation?
Right now, this one isn't pushing remediation. We've done some other things that have gone and tried to push things back there for various reasons. We had another course that we did that was a proof of concept one that was actually one that was built that was actually also kind of looking at cybersecurity, but for one that was a little different and more interactive. You basically had a web page and it would go over and pretend like you almost had like an error in Gift, and then it would ask for you to essentially log in. And then if you logged in, it wouldn't have you log in. It would go over and basically ding you and say, "Oh, we got you. You should have been checking. You should have been checking that this thing had the right URL," and then it would send you through one of the EMAP things about whether or not it would give you sort of remediation for that. So we did do that for a different thing, but not for this one. Okay. The way that works in practice is that the agent module sits there as a module like the other ones, and we basically by default have the agent module subscribe to all the possible Gift messages. So it's basically got like a dot star. It just wants to listen to things. We don't know what specific services want. Then directly after that, it's expected you have a gateway module where the gateway says, okay, here's actually the Gift messages that I care about, and what format do I want those messages to be converted into? Because it was through this superglue architecture that we had built at Memphis and then over at ICT for kind of trying to broaden out from kind of XAPI into a slightly broader set of messages. And so, but we also have some that are just basically containers for Gift messages. They just kind of pass on the Gift messages as relatively raw, but we have some that convert them into other types that are less raw. In this particular case, since we're doing logging, we basically pass them through to services raw. Technically speaking, we have multiple gateways. The gateways can also be used to filter, so only some services are getting some messages and some are other ones. This one was simple because we just wanted that, so we had it just filter out for the ones that we wanted, made sure that they were packaged up, and then when they hit the other service, it would convert them into basically XAPI capable, call through the XAPI call and send it off through a Java XAPI library to be logged. All
right.
So yeah, that was the structure in there, and yeah, that actually worked quite well. Actually, we got there pretty quickly once we had the right messages. We hit one little nit that actually, I guess, the dialogue-based assessments weren't doing all the things that they were expected to do for their logging, and then basically Mike Hoffman, I think, spent about a day on that and just got that one there. People just weren't using that feature, and then we basically had about the data that we wanted. So that was overall very very smooth, actually. So you never know how things are going to go. That was quite good. So, and the stability actually of Gift, looking at the older versions versus the current version, we had very good stability on this set of runs. So, yeah.
So talk a little bit about the fat horse.
Oh, Bob.
I would say that Gift is actually substantially slimmer, and at least, I am biased because I worked on the agent module, but for plugging things in, I definitely found it to be at least easier to put riders on there.
We almost got through the whole day, Bob.
So easier to put riders on there. I would say one of the big things is the authoring tools. If you go over and you look a couple years back versus now, the authoring tools have advanced so much that, I took a summer intern, I put him on that course, and he made basically that course, in like maybe 2 to 3 days.
Yeah.
With, basically about a dozen activities. And most of that time wasn't like inputting the data. It was, there was a little bit of nits that he had trying to figure out. There's still probably a little bit of polish that could be done on sort of tagging with concepts for those sort of things. But overall, that went very, very smoothly. So if you went over and looked back to sort of the very first versions of Gift where you're like installing a database, and you look at now, it's like, okay, you installed this thing, you went in there, you opened it, a person who had basically I didn't even put him in tutorial, he was a computer science guy, but basically said, hey, here's this thing, here it is, opened up, showed it to him for a little bit, showed him the interface. He made that course in like half a week or so for the first version of it. So I mean, they definitely, the speed on going and getting things in there has been really quite excellent. So in terms of module decoupling, there's probably still more polish in there on that. Sometimes I think even for us trying to figure out exactly the right message, because there's everything has its own performance message somewhat. There's kind of some messages which are similar but happen to have different conveyance formats. I think sometimes takes a little getting used to, and might get kind of more normalized over time. But I mean, big transformation since the originals. So
that's good to hear.
Very good. Any more questions? Well, actually, we're 1 minute over time, Ben. So if you have any questions, hit them up in the chat window. So we're gonna move on to the next talk. Another fan favorite name, Dr. Ben Bell, will be presenting on the Magic project.
All right. Thank you, Ben and Ben. Let me share here. Okay. So are you seeing my presentation?
Yep, you're good to go.
All right. So thanks for having this event and for setting it up virtually. I know last night's networking social wasn't very well attended, but it was a small but spirited group. And the work that I'm talking about today addresses a particular slice of what makes authoring intelligent tutoring systems, and authoring in GIFT in particular, challenging. So we've been hearing about some other tools and affordances. Magic addresses a specific slice of that process, which is finding and aligning content with some desired set of target competencies. The work was, so our core and collaborator is Dr. Keith Bronner, and our lead technical person, Debbie Brown from EduWorks, is also in the conference. So if you have any hard questions, please direct them to Debbie. So the vision of the Magic project is to support a very specific part of authoring, but a very time-consuming part of authoring, and that is finding and managing and refreshing content that is aligned with a given set of competencies. And this problem becomes more challenging when we consider the difference between a training system that focuses principally on individual task work and training that is meant to focus on teamwork. So you have that additional challenge of understanding and aligning content that fits into one of those two categories. So an objective of the Magic project is to help really facilitate and accelerate the development and the maintenance of team training by providing tools that can help automate the content discovering and alignment with competencies. In the bigger picture, the objective is Magic is to help extend the reach of tutoring across many more applications in the Army. The Army has a very diverse set of training requirements, and the more that the GIFT community can do to accelerate the creation of tutoring systems, the broader the reach of that capability can be and touch all aspects of the Army training landscape. So more near term, more tactically, GIFT or Magic can particularly help GIFT address some of the requirements that are beginning to emerge in the context of the STI training management tools pillar. So I'm going to talk about magic in two chunks, basically. There's a very high-level workflow that is that sort of captures how magic is used. The first is kind of a one-off. It's the process involved in tuning magic to a particular domain, and that's performed once for any given domain. And the second part of the workflow is once that model is built and trained, how is magic actually used by an author who's creating some training instance? And that can be done over and over. So you see at the bottom of that schematic, there's a corpus on the blue side and the corpus on the green side, and those can be different corpora. So the corpus that is built to train the model to a domain can be different than the corpus used in any particular authoring application, which is good because you want a domain to be able to support lots of different training applications, lots of different corpora, potentially. So I'll talk first about the domain model training process, and it involves creating the training corpus and then employing our machine learning methodology to create these concept maps that I'll talk about in a bit. We applied that method on using 3 different methods, and what distinguishes them is the learning approach. So in one, we used a generic English language corpus with unsupervised learning models. The second, we used unsupervised learning, but we used the domain-specific corpus. And the third, we applied supervised learning approaches with a domain-specific corpus. One challenge, though, in this kind of a machine learning approach is that topic mapping techniques that EduWorks and many others have applied before. In fact, we did work for STTC in this area. But a challenge when we think about competencies is that the content excerpts that we want to align with competencies are being aligned with very, very short text strings. A competency has a very, very short, there's very limited content in the way a competency is expressed. And that short text sample makes it much more challenging than topic detection, where you have large documents and large contexts that you're comparing against. And so in this little blow-up, you can see there's a competency, and you can see how short that text string is. So we had to reinvent the kind of machine learning approach that we would normally use for topic mapping, and came up instead with a concept embedding approach, where we first build a concept map and then instantiate concepts as clusters of related phrases within that space. So I mentioned before that we use 3 different approaches, and I'll show you the first 2 first. So the unsupervised machine learning using a domain general model, we use Wikipedia and also the New York Times corpus of annotated English to create concept maps. In the unsupervised but domain-specific model, we created a corpus of military-related documents. This came from the CAR, the Central Army Registry, which was a collection of Army documents. The third method was to do supervised training, and for this, we used that same corpus, that domain-specific corpus created from the CAR. But then we had 3 trained human raters do labeling in a way that mirrors what an instructional systems designer would do. And they were trained, so we achieved very good inter-rater reliability. And then a quick synopsis of those results, looking at all three of those methods. So first we looked at the unsupervised learning with the domain general model. And there were basically two conditions that we looked at. One is, what does the algorithm say when all three human raters agree? And the second is, what does the algorithm say when there's not agreement? So two of the raters don't agree with the third rater. So in the first case, when all human raters agree, with the unsupervised model and the domain general corpus, the algorithm performs slightly below human performance. Human performance in this case would be a 1.0 because all the raters are agreeing. If you look at the middle column, this is still unsupervised learning, but it's a domain-specific model. We get better performance, and we now see that although the algorithm performs slightly below humans when all three raters agree, when all three raters don't agree, so the human value would be 0.67. The algorithm performs slightly above human levels. And the third case, as you might guess, which is the supervised learning and the domain-specific model, the algorithm actually, when all the humans agree, it approaches, it's almost at exactly 1.0, so it approaches human performance. And when the humans disagree, the algorithm performs actually above mean human performance. In other words, the algorithm agrees with the majority more often than the human who was in the minority did. So if you sum all of the runs in that third column, the net result is that the algorithm actually exceeded human performance. So that was a very brief look at the process of creating the domain model. I want to talk now about how that's actually used. So now that we built the model, what is it good for? And I'll talk about three elements of this workflow. The first is creating the corpus. The second is defining the competency framework. In other words, what is the content that we're looking for? What competencies do we want that content to align with? And the third is what to do with the results. The corpus came from lots of different source documents, mostly from the CAR. So this is a quick look at some of the documents that we've extracted from the CAR. The domain is Army infantry maneuver, specifically infantry battle drills. So Magic begins by having the user create or define the corpus. And in this screen grab, you can see a regular sort of document hierarchy, folder hierarchy, and those can be toggled on and off. And what that means is that you can customize and modify the specific corpus that you as the training developer would like to be working with. The second step is saying, well, what do we want the content to be about? What learning objectives do we want that content to support? And that's represented as a CAS framework. So at this stage of the workflow, the training developer imports and selects a CAS competency framework. And so we had previously created those. So you can see in this case, we're selecting the competency framework corresponding to Battle Drill 10. So this is CBRNE domain, how to react to a chemical attack specifically. And within that competency framework, the individual competencies can be inspected, and the training developer has the option to turn them on and off. You might not want to be building training for the entire competency framework. It might have a specific focus, for example. So in this case, in this example, the training developer has selected the competencies within the framework that are checked in the box. So this then becomes analogous to the course, or the course segment that the training developer is building. So what Magic is now going to be asked to do is to go out and find content from the corpus that supports one or more of those selected competencies. So this screen is following the analysis that Magic does, the extraction, where it searches the corpus and does those extractions. And it's not a fire and forget solution. So the training developer has the opportunity to look at the results and say, yeah, I want this, and no, that's no good. And so the example here, the content that it found is displayed in that middle pane. And the search can be filtered, so even after the results are displayed, the training developer can turn documents on and off that are being searched from the corpus, and can also go back and change which competencies are being searched for or are being aligned with. You can see also a small filter at the top, which is task type. So I mentioned before, Magic has the ability to distinguish between content that is principally aligned with supporting team training objectives versus content that is principally aligned with supporting individual learning objectives and competencies. When the training developer sees one of those excerpts and says, yeah, I want to dump this into my system, then they can select it and drag it over to the leftmost pane. So the content that is being displayed are basically these search results, and the dragging it to the left is the act of saying, yes, as the training developer, I want this piece of content to support the selected competency, which is displayed with in that blue shaded area on the left. As the training developer is selecting those excerpts and building them as content under that competency in the left, Magic is displaying on the rightmost pane how that chunk of text actually appeared in context in the original source document, because it may not always be clear. So this is a display of the competencies, or the elements of the battle drill that the training developer selected for this analysis. And so those are that middle set of nodes to the right of the course. So those are the competencies from battle drill 10 that were active in this example. And as the training developer selects content that Magic discovered, those appear under the corresponding competency. So far, the topmost competency has 4 results attached to it, 4 bits of content that Magic automatically extracted from somewhere in the corpus that aligns with that particular competency. So during the course of the project, in discussions with Keith, and based on Keith's discussions with his colleagues at PEO Stry and STI and elsewhere, we looked at how Magic could support finding content that aligns with not only competencies, but maybe other sources, other enumerated lists. So we did experiments where we aligned content with fragos, with fragmentary orders. In this example, we used TSPs, for training support packages, which are the instructional package that accompanies a VBS4 or VBS3 package. So in this experiment, rather than inputting a competency framework, the training developer said, here's my competency framework, but don't search a document corpus, search TSPs. And what you see are the results of Magic's alignment. So it's extracting documents from those TSPs that support a given set of learning objectives. And I don't know if you've actually ever seen a TSP, but it's the VBS3 scenario, and then a whole lot of stuff as a very comprehensive collection of documents that go along with a scenario. This is in the Mill Gaming portal. So I want to conclude with talking about Magic's integration with GIFT and what may be coming next. So we've been devoting this portion of the project to creating APIs to make it easier for other systems to make use of Magic. It's already integrated very readily with CAS, and in terms of GIFT integration, we see Magic as a layer of services that can support authoring in GIFT Cloud. So some integration points that we see as making sense fall into the categories of the basic content alignment, managing or curating the content, and then packaging it. So for the content alignment, as you saw, Magic can take some competencies and then go find content. But because GIFT has been undergoing some growth in terms of supporting team training, Magic can also align content by the specific role within a team. It could be driven in that regard by the team organization DKF that Ann told us about this morning. So Magic already does some preliminary identification of team roles, but we shelved that part of the research because we wanted to mature the API. But that capability is there. It could be better, but it's there. In terms of the curation, Magic helps to import competencies and to find content that supports those competencies, but it's using CAS framework, so that promotes the integration of Magic into the GIFT ecosystem. Magic also supports, as you saw, a little bit of the review and validation of Magic's results. And then finally, in terms of packaging, a logical integration point is for Magic to support exporting those findings into the content that is an organic part of the GIFT authoring workflow. And in particular, what I mean is that the export format should align with whatever format was the originating GIFT component format. So the results of the project validate the concept of automatically tagging content to support desired competencies. Some preliminary algorithmic results approach human performance, and with supervised learning, it can exceed human performance. And it's not limited to competencies. We did those experiments with other expressions of what we want to find content for AGOs and TSPs. So use of Magic can help accelerate the basic GIFT authoring workflow. It can promote reuse and repurposing. And it can help GIFT better address a broad diversity of Army training requirements, including those that are emerging from the STEED TMT. So the future work basically falls into either research or transition. The future research objectives would be to improve how Magic flags content is aligning with specific team roles, perhaps making use of the team organization DKFs. And also we want to expand Magic to be able to align content that isn't in text form, either through automated transcription or through the use of metadata attached to that media. In terms of transition, I mentioned we were emphasizing in this phase of the project creating a robust API. That's because we want to be able to demonstrate it with a broad range of possible Army content management or learning management tools. And part of that will be to actually do an evaluation of Magic using people who are actually in the process of building training. So I thank you for your attention, and I believe there are time for questions. There is time for questions. Thank you.
Thanks, Ben. So let's open it up. Any questions there?
Can I ask you a question?
Sure.
Please explain how you define the semantic. Thank you.
Good question.
Ben, this is Ben. How does this technology associate with multimedia content? And how does it identify content that might be team-oriented but specific to a given role?
So the answer to your first question on processing non-text content, there are two answers. One is to use the metadata associated with that media. So in the case of TSPs, as you know, a VBS scenario is non-text, but a TSP has just like megabytes and megabytes of text that support that TSP. But in other cases, we would rely on some automated transcription techniques that we've applied in some other projects, or even the automated transcription doesn't even need to be sort of perfect from an English language or a human reader's perspective. It just needs to express the right content for that kind of matching. So, so your second question is, how do we distinguish individual and team content? That's probably an answer that is best expressed in a sidebar. It's complicated, but basically I'm not even sure I could boil it down into a succinct answer, but it's using the same concept embedding techniques. And it works much better in the supervised training model, but because the human raters were very adept at flagging that. But I think I'm going to have to research that and get you a more robust answer, Ben.
No problem. All right, thank you. Okay, so we have the last presentation of the first day, and it's a familiar face. Dr. Robert Sotoler joining us. For those who don't know the history of GIFT, he was leading the program back in 2010 when all of this got started. He's gone on to industry, so we're going to get a good update from him on the IEEE work and the standards for AIS. Thanks, Bob.
Okay. All right, thanks for having me. Let me share my screen. Share screen, and yeah, allow that. Okay, that's good. Okay, go here. All right, can you see my presentation?
Not yet.
Okay. All right, let's see here. What's going on? All right. And why is it doing that?
Yeah, if you hit share, you have to then select like what window you want displayed. There's like two.
Okay, share. and PowerPoint. There we go. All right. Check back in a bit. All right, hang on. All right. Let me do this. Is it up?
Unfortunately, it is not. I'm not seeing it.
All right, third time's a charm here. Let's try again.
Not yet, but I will accept you trying to pictogram it with the hieroglyphics on your couch pattern.
Okay. All right.
If you want, you can try and email it to me, and I can go through the clicks for you.
Okay. Yeah, because it doesn't seem to be letting me do this. Why? I don't know. One more time. Share. PowerPoint. No, it's not doing it. Yeah. Nope. Yep. You can see my messy office. All right, there we go. All right, let's not do that. All right, let's go here. All right, let me give me a second and I'll email it to you.
Okay, if you want, you can even attach it in the chat box.
Okay. Although I think I'm restricted from using the chat. Yeah, it's disabled for me. Nope. So, all right, now let me just email it to you. All right.
While he's getting that taken care of, I'm happy to say that the proceedings is now available. So if folks go into the chat window, I just entered a link that will take you to the landing page to get the proceedings.
All right, Ben, it's on the way.
Hopefully it races through the firewall.
Yeah.
I don't know if there's any like intro that you want to talk to while we wait.
Yeah. So let me get out of this window here and go to this. I gotta back into Teams. Okay. So so I'm going to talk a little bit about what's going on with IEEE. Keith touched on it a little bit this morning, and that group is the working group for 2247, which is adaptive instructional systems. Has been going on now for about a year and a half, and has 3 subgroups. So I'll talk a little bit about the groups, what they're doing. I'll talk a little bit about how you can get involved with those things. And as soon as Ben has the slides up, there's a little bit of on the front end, what we're trying to do in terms of standardization and recommended practices. And, IEEE is a standards body, been around for a long time. You live with a lot of their standards today. In fact, wireless internet, 802, IEEE 802. There's, if you look at the plugs in your room, whether they're, wired internet or whether they're electrical plugs, they're based on IEEE specifications, so that there's interoperability, right? So if I have a plug and in my house and I go to somebody else's house in the U.S., there's a standard for that, and I can plug in, and right. Same thing with Wi-Fi, and seems to be working pretty good. Ben, you just interrupt me when you got the slides up.
They just arrived as you said that. I'm pulling them up, so give me 5 seconds.
Okay. So yeah, so this will give you an idea about, there we go.
Which slide do you want to go to?
Yeah, go to the second slide. And so I show this slide a lot, but it helps explain, differences between adaptable systems like your phone, which as a user, you can control how you use that, how you interface with it, what apps are there. and it's flexible to whatever your needs are. And my needs might be different than your needs, so mine, my system will look a little bit different. So a phone is a smartphone is a good example. But in the case of adaptive systems, basically what you're doing is you've now got some kind of adaptation logic, artificial intelligence that looks at the environment and makes decisions about how to adapt the system instead of having the user do it, right? And this is what we're talking about in terms of adaptive instructional systems. We're talking about systems that are going to be responsive to the needs of a particular learner, and it may or may not be transparent to that particular learner or team of learners. Next slide. Okay, so I show this one a lot too. Again, if you're, you sat in on Ben Nye's talk about, agent-based interaction in terms of instructional systems, right? An adaptive engine that's there, it may be agent-based, interacting with some set of learners, interacting with some instructional system, a simulation or a game, and that and that system is set up so that it can improve over time, right? It's pulsing what's going on with the learner. It's pulsing what's going on with any particular scenario or any part of the environment that that learner is operating in, and then makes adjustments in order to pursue the goals of that particular domain of instruction. Next. All right, so yeah, here's some definitions. I'm not going to go through definitions, but this is a paper based on a paper that Keith and I wrote a couple of years ago. And this idea of guiding learners, right, to be able to provide an experience and to automatically adapt in terms of maybe challenge level or in terms of interaction with a particular user based on their preferences. Next. So why am I telling you all this stuff, right? That's right. I'm telling you because there's lots of different kinds of adaptive instructional systems, and they operate in many, many different ways. GIFT is one of those systems. If you just look at a hierarchy of systems, an ontology of systems, you have intelligent tutoring systems, you have intelligent mentors or recommender systems, you have different kinds of intelligent instructional media, and that media is that those systems work in different ways. They have different ways of setting objectives, different ways of assessing what's going on with the learner in pursuit of those objectives, and then different ways to intervene. And so when we look at these things in lots of detail, it seems, wow, it's incredible that there would ever be any kind of standard for these things, because they've all been built by different people for different purposes, different domains. And this is part of the impetus and the motivation behind building GIFT. Next. So like I said, there's lots of different systems out there. You get GIFT and Auto Tutor and Texas and the Cognitive Tutor and Aspire, and there's many, many, many more systems that are maybe have some kind of adaptive instruction embedded in an environment, right? Not separate from it. Next. So with all that said, there's lots of different choices. And what we're attempting to do is to say, hey, if we could promote reuse in some way and promote interoperability, again, think standards, if we could jumpstart development where people want to come into this arena and build systems and be able to reuse elements of those systems or whole systems, services, Ben just talked about services. To be able to bring new solutions into the marketplace. This is the idea behind standards, right? And so the idea is not to interfere with everybody's secret sauce, so to speak, but to help people who have secret sauce, bring it to a market and make it available. Wow, that's a nice mountain. And to make it so that they can come into the market and people can consume their secret sauce, right? And so when you think about this, think about standards and think about IEEE without the G on the end. I don't know where that came from. All right, next. Okay, so so we have this project that started year and a half or so ago. It's Project 2247, Adaptive Instructional Systems, Standards, and Recommended Practices for those things. Right now I'm the chair. Eric Domashek is from Stotler-Henke is the vice chair. Drew Hampton is the secretary, and Jody Cockcroft is treasurer. Those folks are all working hard to keep this train moving along. And, you know, I appreciate all the work that they've done. So I'm briefing you. This is probably one of the last things I'll be doing as the chair for this this particular working group, and I'll talk a little bit about that in a minute. So next slide. Yeah, so so here's kind of a hierarchy or landscape of what's going on with IEEE standards related to adaptive instructional systems. So the AIS working group is part of something called Learning Technology Standards Committee. That committee was chaired for years by Avram Bar, who we all know and love, and Richard Tong, who we're all getting to know and love. So so Richard's really working hard to, you know, he's gotten up to speed now, and there is a ton of stuff going on in the LTSC besides adaptive instructional systems. There's all kinds of things going on with competency modeling and different interoperability standards to allow for interaction of learning technologies. So I highly recommend that, you know, drop Richard a note, not to bombard him, you know, but if you're interested in learning more about that group, he can give you access to the sites. And then you can, you know, you can register and go in and look at what's going on, including adaptive instructional systems. Yeah, and I have the future chair of the group. I'm bailing on the 1st of June. It's just become very difficult for me to keep up with this and the other 99 irons I have in the fire at this point. So I'm going to turn the reins over to somebody. Richard's going to pick somebody here in the next week or so, and they'll be moving along. Now, there is a monthly meeting. It's the second Thursday, 10 Eastern, and it's on Join Me. And under that, IEEE-CAIS. And then there are 3 subgroups. Let me talk a little bit about the subgroups. This first group, the AIS Conceptual Modeling Group, chaired by Ann Knowles. There are a number of people who have contributed greatly. Jim Goodell and Vlad, who was asking questions a little bit earlier, have been instrumental in putting together the conceptual model. And the conceptual model is basically to describe what is an AIS and what is it not, right? We have to start someplace, right? And, you know, if you were trying to describe a specification for, you know, I don't know, a pen. Here's a pen. There we go. We can get it in the picture. Yeah. There we go. All right. So I would describe it. It's got a tube in it, and the tube has ink, and it's got a little button to move the ball in and out, and it's got a place to grip it, and you know, you hold it in your hand and you apply it to paper and write stuff, right? And so, you know, and so something that's a pencil is not a pen, right? It's something different. And so that's going to be important, especially when you talk about the next group, which is looking at interoperability. How do I take data, right, and move it from one system to another, or share it between systems, even if it's not in real time? So there is, you know, an opportunity there to even at the component level to share information or standardize messages between what might be standard components defined in this conceptual model. All right. And then finally is the evaluation subgroup. Is they're looking at, hey, how do I, if I want to, have one of these things and it meets, the conceptual model of what an AIS is, and it meets interoperability standards and data can be traded between them, then, how do I take that and then evaluate it, whether it's in terms of how data flows, or taking the information and reusing it in some way, or understanding its effectiveness. And so the evaluation subgroup is looking at, how do we define assessments or evaluations to determine the capabilities within a particular AIS or set of AIS technologies. All right, next. And that's it. All right. So thank you for the opportunity to talk to you. I know I'm between you and the end of the day, but I'm ready for questions if you have questions about anything I've talked about.
Thanks, Bob. Any questions? Of those 3 sub-working groups, which one is making the most headway regarding standards?
Yeah, so the conceptual modeling group's been around and kind of hitting the ground the longest. So they have a draft standard at this point that has been reviewed at the working group level, is now being resolved to answer the comments that we received in the first round, and then it'll go to the LTSC. The LTSC will sponsor a review, and at that point, we can make a determination depending on the number of comments about whether or not that's going to go to a balloting group. The balloting group will be formed, and people will, review it, make comment on it, and this will be done, in accordance with IEEE's review standards. So, so that's exciting, and we're getting close on that group. The interoperability group has been around the second longest. We had a change of chairmanship when Richard Tong left that subgroup and moved into the LTSC position. And so Jim Goodell has taken over there, and he's starting to have regular meetings now. The other thing that slowed us down was, we just needed to have at least a draft conceptual model before we could move forward on interoperability and even discussing what might be passed between elements of AIS is very difficult if you haven't defined what those are, right? The next group is that subgroup that Shelley Blake Block is chairing. They have very regular meetings. They are humming along. Probably by about October, I expect to see a draft out of them. It will probably not be a standard. It will be a recommended practices document. All right.
Very good. I saw some action in the chat. It looks like if you're interested in getting more involved, I'm resharing the email addresses so that folks can reach the point of contacts that are most appropriate. Drew Hampton is mentioning you can also reach out to him for access to the meeting information. Yeah, I think it's an important endeavor, and the more folks involved, the better.
Yeah, I think we're going to see not just the commonality to drive the standards, not just the interoperability piece, not just the evaluation piece, but we're also going to see in practice, once these standards are set, how people actually use them, right? The standards are no good if they're not used. So it's going to be important for people to use them, and it will help, I think, drive forward the technology that we're describing as adaptive instructional systems. including systems like Gift. So it's good for the whole community, and it's definitely going to be good for the economy if you're in this business, right? So lots of capabilities to be produced coming out of standards.
Awesome. Any other comments? Drew, did you want to add anything?
Just that join me link might not be current, but again, if you're already in the working groups or the subgroups, you'll get updates. If you're just thinking about joining, then let me know or one of the subgroup chairs, and we'll make sure that you get on the mailing list with the updated information.
Yeah, if you can put Drew's email address in the chat, that would be helpful, and make sure that people can get a hold of him. Yeah, so Drew's one of the candidates to be chair. So,
all right, very good. Any other comments, questions? Jody, put another link in the chat for those interested in some more information.
Mm-hmm.
All right, great.
All right. Thank you very much. I appreciate the time and the opportunity to be here, and so it's like a class reunion, right?
Yeah, it's hard to believe that this is the 8th one of these.
I know.
Yeah.
Keep it going, man. Keep it going. If you can make it happen this year, no other year is going to be as challenging.
Okay, we'll put those words in stone.
Yeah. And congratulations. Lots of good stuff going on with Gift.
All right. Well, appreciate it. So we can go ahead and conclude day 1. Tomorrow is only going to be a half day. Let me pull up the agenda just so that folks can see it. It's going to start at 8:30ish with the first talk at 8:45. Tomorrow will be a heavy focus on what we're doing in the space of team intelligent tutoring and its impacts on the synthetic training environment program. So there's going to be some really good information to share on that. Let me just pull this up real quick. So another important item is tomorrow has a different Microsoft Teams link than today. So make sure you click the correct link. And I will add another news announcement to gifttutoring.org in case you need a place to find the agenda. So with that, I'll open it up for any questions, and then we can call it a day. One feature that I want Microsoft Teams to add is a raise hand option. Okay. So with that, I see Janine. We also post. I would be happy to post the Teams link on gifttutoring.org when I do the news announcement. I'll add it there. All right. Thanks, everyone. Same place, same time tomorrow. Different link.
Thanks.
Thanks, Ben.
Thanks,
Thank
everybody.
you.
Have a good day.
Thank you.
Thanks, Ben.
Thank you. Bye.
Thanks, Ben.
Bye.
Bye.
Thanks, Ben.
Thank you, Ben. Thank you, Orlando team.
Take care, everyone.
Bye.